The figure shows a jogging track in the shape of a rectangle. This is your rectangle with semicircle on both ends. The perimeter of the track is 400 meters. So the perimeter, okay, the length of this track is 400 meters. And the expression for perimeter, so you need to think of how do we get the perimeter length from this track. We need to add this section right here, which is your y. So you have got another y right here, means that you already have 2y. So 2y. And then we need to plus with the length of this arc. So you have got, okay, one arc right here and another arc right here, and this is actually the circumference of a circle. So think of the formula for circumference of circle. So circumference of circle. So let me draw a circle for you real quick. So this is a circle, and the circumference of a circle is given by this formula pi d, or you can also write it as 2 pi r. So 2 times r is basically diameter. So diameter looks like this. From side to side, we call this diameter, but from center to side, we call it radius. So for this track right here, if we combine these two semicircles, we will get a single circle, right? So we can just use the formula of pi d for our length of arc. Since our d, the diameter of this semicircle is x, so we can change this d into x. So our arc length will be pi x. Now we can rewrite our, we can answer the first question right here. A, obtain an expression for y in terms of x. So we need to express this y in terms of x. Okay, given the value of perimeter, we can directly substitute 400 into this equation, equals to 2y plus pi x. So we can get the 2y 400 minus pi x, and y equals to, so let me move this, all this down here. Okay, so y equals to 400 minus pi x divided by 2. So that is your expression of y in terms of x. Now show that the area of the track is given by a equals to 200x minus pi x squared divided by 4. What we need to know now is what is the formula for area of circle. So area of circle and the area of a rectangle. So the area of a circle is given by a equals to pi r squared, and the area of a rectangle is based on this track right here. It is equivalent to x multiplied with y. So xy is the area of a rectangle. So the first one just now was the area of circle. So in order to get the total area, you need to add them up. So the total area is pi r squared plus with xy. But now we need to express our r in terms of x. So if we look at this track once again, this x represents the diameter. Means that half of this x will be the radius. So r is equivalent to x divided by 2. Therefore, our r is x over 2. So now we can substitute that x over 2 into this r. So x over 2 square plus xy, and then we get pi x squared over 4 plus xy. So your a is now pi x squared divided by 4 plus xy. Now our next task is to differentiate this a. Okay, this area we need to differentiate it. But the problem here is that we are having multiple expressions. So what to do next is to reduce this expression so that we can only have a single expression. Okay, from this equation right here, we can see that our x is more dominant than y, so we can express this y in terms of x. Okay, from the expression that we obtain in question A, okay, from this question we actually get our expression of y in terms of x. So you just get this y value and substitute it into that equation. So we will get this equation right here, and then we need to substitute that y. So we rewrite this equation as x multiplied with 400 minus pi x divided by 2. Then we can multiply it in. You get 400x minus x squared pi x squared divided by 2. So this will be your new equation. But the problem here is that we don't have the same denominator. So what we need to do now is to make a common denominator, okay, by simply finding the lowest common multiple for these two. So the simplest way to do it is just by multiplying this side by 2 and multiplying this side by 4. So what you're gonna get now is 2 pi x squared divided by 8 plus with 1600x minus 4x for pi x squared divided by 8. So since we now have our denominator the same, we can combine this denominator. So we will write it as 2 pi x squared plus 1600x minus 4 pi x squared divided by 8. Now we can further solve this equation, and then we get negative 2 pi x squared plus 1600x divided by 8. And lastly, we will get, let me rearrange it so that we get our positive value to the front, okay, minus 2x squared divided by 8. So what you're gonna get at the end is 1600 divided by 8 is 200x minus 1 over 4 pi x squared. So that will be your final area formula. So the next thing to do is simply getting the derivative of this area. So we get the dA dx equals to 200 minus pi x over 2. So that is the first derivative of this formula. So then we need to let our dA dx equals to 0. 200 minus pi x over 2 equals to 0. Then we bring that 200 to the right hand side. It becomes negative. Then we can cancel out both of these negative. Then you can multiply with 2, you get 400. So x equals to 400 divided by pi, or the value in decimal is 127.32 meter approximately. Next, what we need to do is to get the second derivative of this formula. So the second derivative will be d2a over dx squared. So the second derivative of this formula will be negative pi over 2. And that's all. Negative pi over 2 will be our second derivative. Since we have got our value of second derivative as negative, okay, negative of something, pi over 2, you can think of it, means that we can conclude that our d2a over dx squared is lesser than 0, means the value to be evaluated, which is the area to be evaluated, is maximum. The area is maximum. So let's look at the question back. Determine the value of x so that the area of the track is maximized. That is why we get the second derivative as negative. So what is the x value then? It is actually the x value that we got from the previous process, which is this 127.32. That is actually the answer for the last question. So the x value that we need to find is basically that 127.32, and that is the area, that is the value of x that we need to have in order to maximize the area of this track. So that is the solution for this question.